All right, Mr. Diego here from Mr. Diego Tutoring on Instagram and Crushing Chemistry on YouTube. Today I brought you an IB style question, paper 1A style. It's about reversible reactions. It's about Le Châtelier's principle. So let's begin. Which pair of changes will both shift the position of the equilibrium to the left? Now, the changes in question are temperature and pressure. So here are the rules. Every time you increase the temperature, you're providing the reaction with more temperature, with more heat, with more thermal energy. The reaction is going to shift to the endothermic side. And that might vary, just like pressure, from reaction to reaction. We need to see our specific reaction here, what's the case, and I'll teach you that in a moment. But the rule of thumb is every time you increase the temperature, you're shifting your reaction to the endothermic side, which is the side that absorbs heat. So increase the temperature, shifts to the endothermic side to absorb that extra heat you're providing. What about pressure? If you increase the pressure, that means you're decreasing the volume. You're giving the reaction less space. And if you have gaseous substances, molecules, compounds, that means that you are shifting the equilibrium towards the side with the lowest amount of gaseous moles. And that makes sense, right? If you're increasing the pressure, you're actually favoring the side with the lowest amount of gaseous moles. Well, our question here wants to know what we need to do to shift the reaction to the left. So let's start with pressure. So you can see that the reactant side, the left side, has 2 moles of hydrogen gas plus 1 mole of carbon monoxide, which adds up to 3 gaseous moles. While the product has 1 mole of methanol gaseous, so that means that the left side has more moles of gas. So what do we do in order to shift a reaction to the side that has more moles of gas? Well, I just said that if you increase the pressure, it will shift to the side with the lowest amount of gas. In our case, is the right. So we want to do the opposite. If we decrease the pressure, it will shift our reaction to the left in this case, because the left side has more gaseous moles in this specific reaction. So in this case, if the question wants to shift to the left, we need to decrease the pressure. Now, what about temperature? Well, it's the rule of thumb that if you increase the temperature, it will shift to the endothermic side. Now we need to figure out which one is the endothermic side, because it could vary from reaction to reaction, right? Well, it was provided for us right over here that the delta H is negative. What does that mean? If the delta H is negative, it means that your forward path is exothermic, that your forward path is releasing energy. So in that case, if we increase the temperature, we are going to be shifting our reaction to the left, because the left is the endothermic path, okay? And this is always going to happen. If you increase the temperature, it will shift to the endothermic side. In our case, the endothermic side is the left side, because it was presented for us that the delta H of this overall reaction is negative, which means that the forward path is exothermic. And by elimination, I only have 2 paths. If the forward path is exo, the left path is endo. So we need to increase the temperature to shift to the endothermic side, and we need to decrease the pressure to shift with the sides with the highest amount of gaseous moles. So increase the temperature, decrease the pressure, alternative C. And that was Mr. Diego Tutoring for the day. For more questions of Le Châtelier principle and all other things related to IB Chem, follow me on YouTube at Crushing Chemistry and here on Instagram at Mr. Diego Tutoring. To book a session with me, send me a DM or send me an email. The link's on the bio. Thank you so much, and I see you next time we crush some IB chemistry questions. See you later, y'all. Have a good one.